Next, we'd like to talk about the steps to find zeros of any polynomial. First thing I want you to do is list the possible rational zeros. Next, I want you to use the factor theorem to determine if any of those possible rational zeros is an actual zero of the polynomial. And in order for it to be an actual zero of the polynomial, we're going to use synthetic division and look for a remainder of 0. Once we have a remainder, that means we can use a factor theorem to list out the new factored polynomial. Next, step 3 says rewrite the polynomial as a product of the factor of the quotient. And if the quotient, the leftover polynomial, is factorable or it's quadratic, then I want you to factor and solve. And the important thing here is to note quadratic. We would like to get it down to a degree of 2 because we can solve any quadratic equation using factoring, square root method, completing a square, or quadratic formula. There's lots of different ways we can get there. But as long as we can get it down to quadratic, we know we've got the rest of the problem. Now, if the remaining quotient polynomial is not factorable or quadratic, then you need to go back and repeat steps 2 and 3. You need to keep factoring and using synthetic division to look for a zero remainder until you can get the remaining polynomial to be quadratic. Let's try some examples. We have a polynomial function that we are unable to factor using any of the factoring methods that we've tried in the past. So, because I can't factor it using my own skills, I'm going to list the possible rational zeros, which was the first step, which means I'm looking for the factors of the constant term, which is -3, and divide that by the factors of the leading coefficient, which is 1. The factors of 3 are plus or minus 1 and plus or minus 3. The factors of 1 are plus or minus 1. And when I divide that out, I'm getting a possible rational zeros of 1 divided by 1 is plus or minus 1. 3 divided by 1 is plus or minus 3. So first off, we have the list of possible rational zeros. So I'm really hoping that this function that we were given has at least one rational zero in it. In order to figure that out, I'm going to use synthetic division. I'm hoping to get a remainder of 0 that I can use the factor theorem. So I'm just going to go ahead and use 1. And I'll go ahead and do my work over here. I'm picking 1 because it's something in my list. Normally I would just let a student call out one of these 4 numbers and we just randomly try them till we get it. But I guess I'll just start with 1 today. 1, 7, 11, and -3 are my coefficients. And I need you to understand that I don't know what the answer is here. I'm just going to try one of them. I'm not picking one for any good reason other than it's one of the 4 things in my list. So let's use synthetic division. 1 times 1 is 1, add down. 8 times 1 is 8, add down. 1 times 19 is 9. This is not working. Okay, so 1 is not a 0. Therefore, x minus 1 is not a factor. So I like to cross that out so that I'll come back later. I realize, oh yeah, that didn't work. Next, I'm going to try -1. So that gives me 1 times 1 is -1, add down 6. 6 times -1 is -6, add down 5. 5 times -1 is -5. That's not getting me a 0. So again, I'd like to cross out -1. These are not working for me. So I have either 3 or -3. Let's try 3. Notice I'm not getting them right every single time. You just keep trying until you find that 0. 3 times 1 is 3, add down 10. 3 times 10 is 30, add down 41. This is not looking good for us. Yeah, that's not going to work. Alright, so 3 doesn't work. So I'm really hoping -3 works because that's my last rational 0 from my list. 1 times negative 3 is negative 3, add down 4. 4 times negative 3 is negative 12, add down negative 1. Negative 1 times negative 3 is positive 3, and negative 3 plus positive 3 is 0. Yay! I'm very, very excited when I get a 0 there, because that 0 tells me that negative 3 is a 0. Yay! Which means that x plus 3 is a factor. The remaining quotient or polynomial I have here at the bottom is now quadratic. Yay, that's what I was asking for. Remember on our steps it says if your remaining polynomial is quadratic, then you know you've got it, because it either can factor or you can use quadratic formula in order to find all the zeros. Does this quadratic factor? Well, it doesn't really factor with nice coefficients, so we're going to leave our factored form as x plus 3 times x squared plus 4 minus 1, and that's our factored form. So what are my zeros? Well, I know one of the zeros is 3, but because I have a degree of 3, that tells me that I need 3 zeros, and I only have 1 from the linear factor. From this quadratic factor, I'm expecting 2 more zeros, and the way I'm going to get that is either complete the square or quadratic formula. I'm going to choose quadratic formula. So I do x equals negative b, which is negative 4, plus or minus the square root of b squared, 4 squared is 16, minus 4 times 1 times negative 1, all over 2 times 1. (16 plus 4 is 20. The square root of 20, which is 4 times 5, is 4 plus or minus 2 square roots of 5 over 2. And 2, 4, and 2 can all be divided by 2 or factor out a 2 in the numerator. Negative 2 plus or minus the square root of 5 all over 2. And those two 2's divide out. So the other two zeros would be negative 2 plus or minus the square root of 5. And I have found all of the zeros which I was asked to do. On the test, you'll be given points for all of the steps along the way, possible rational zeros, being able to factor it, if you find a zero, if you get the factor form, and if you get all your zeros. Notice that we started with a cubic, so I needed 3 zeros. In order to get a cubic down to quadratic, I needed to find at least one linear term. Let's take a look at the next one. The next one is an x to the 4th. In order to get x to the 4th down to a quadratic, that means I don't have to just find one real zero. I have to find 2 zeros, hopefully from my possible rational zeros list, before I can get down to quadratic, and then I can factor. So let's go ahead and list the possible rational zeros, which are the factors of the constant term 13 over the factors of the leading coefficient, which in this case is 1. The factors of 13 are plus or minus 1 and plus or minus 13. The factors of 1 are plus or minus 1, which makes the possible rational zeros 1 over 1 is 1, 13 over 1 is 13. Next, I have to test that. So I'm going to either try 1 or negative 1 or 13 or negative 13. 13 doesn't sound like a lot of fun to me, so I'm going to go ahead and try, we'll try 1. How about that? So I have 1, negative 6, 22, negative 30, 13. How is it that I chose 1? Well, I only chose 1 because it was one of the 4 things on my list. I don't have any other information knowing that 1's going to work or 1 doesn't. The last time we had to try all 4 before we found one that worked. So you're just kind of picking one and hoping it works. Let's synthetically divide here. 1 times 1 is 1. Add down, negative 5. Negative 5 times 1 is negative 5. Add down. 17 times 1 is positive 17, add down is negative 13, and negative 13 times 1 is negative 13, and yes, I get a 0. That is very good news, especially because I'm going to have to keep trying until I get a 0 here. So getting a 0, reason to celebrate, because you're done. You got the 1, 0. So yay, I like to circle that, because 1 is a 0, which means I can rewrite f of x as x minus 1, because if 1 is a 0, then x minus 1 is a factor, times the remaining polynomial down here, x cubed minus 5x squared plus 17x minus 13. Sorry, I'm running out of space there. But I still have a cubic, so I got to keep going. What do I pick from? Well, I have to go back and pick from my possible rational zeros. And here's a little trick that I'm going to let you in on. If you get a 0 of 1, and you have to go again, I like to try that same 0 again because it might be a multiplicity of 2 or a multiplicity of 3. You don't really know. So before I go on to -1 or 13 or -13, I'm going to try 1 again. And instead of rewriting this over again, I'm just going to synthetically divide right under it. I'm going to bring the 1 down. 1 times 1 is 1. Add down -4. -4 times 1 is -4. Add down is 13. 13 times 1 is 13. Add down is 0. Yay! Look at that. 1 not only was a 0, but it was a 0 twice, or what we call multiplicity 2. So I can again rewrite this polynomial as f of x is equal to x minus 1 times x minus 1 again, times the remaining polynomial, which was down from x to the 4th to x cubed, and then down from x cubed to x squared, so that's 1x squared minus 4x plus 13. Did you get this down to a quadratic? Yes, you did. Now that I have a quadratic, I'm going to just factor if I can. If I can't factor, then I'll have to use quadratic formula. Can you factor x squared minus 4x plus 13? What a bummer, you can't. So my factored form, I'm just going to move down here. F of x equals x minus 1 times x minus 1, or I'm just going to write x minus 1 squared to save a little room. And that's my factored form. I know the zeros are 1 multiplicity 2. That takes care of 2 out of the 4 zeros. Remember we said a degree 4 has to have 4 zeros. In order to find the other 2 zeros, I'm going to use the quadratic factor, and I am going to use quadratic formula. X equals -b, which is the opposite of -4, is 4. Plus or minus the square root of -4 squared is 16 minus 4 times 1 times 13 all over 2 times 1. Working just the inside, I'm getting 16 minus 52, which is -36. Reducing that, I'm getting 4 plus or minus 6i over 2, which then reduces to 2 plus or minus 3i. So my other two zeros are 2 plus or minus 3i. I have now found what I was asked to find, which was the zeros. I have 4 total zeros, 1 multiplicity 2, so that's 1, 1, 2 plus 3i, 2 minus 3i. That's all 4 of the zeros.